Graphs are one of the most useful and most used data structures in computer science when it comes to modeling real life. In short, a graph is simply a set of values that are related in a pairwise fashion. And you can see over here, it looks like a little network. There's connections to different nodes. In a graph, each item is called a node or a vertex. So this is a node, this is a node. Nodes are then connected with edges. So that's an edge, and that's an edge. And as you can imagine, graphs are great data structures to model real-world relationships, representing links. Graphs are ideal for cases where you're working with things that connect to other things, kind of like how the internet works, right? We can use graphs to represent maybe friendships, maybe family trees. We can use graphs to represent networks and the World Wide Web. Or we can use graphs to represent roads, one city to another, and the roads that connect it. As you can imagine, Facebook uses it for their social network, Amazon uses it for their recommendation engines, and Google Maps uses graphs for determining the shortest path to where you want to go. So let me ask you a question. Do you think this is a graph? Well, yeah, obviously, we just went through it. What about this? What about this? And this? And this? What about this one? All right, finally this. Just kidding, a few more this, and this, and this. Yep, they are all graphs. Even this one that kind of looks like a linked list, that's a graph. As we saw, there are many types of graphs. But there are certain characteristics that allow us to describe graphs. Let's go over them. One thing that you really want to get yourself familiar with is the idea of directed and undirected graph. These types of graphs are useful for describing traffic flow, for example, of some kind of a system in which movement is not bidirectional. That means, unlike here where I can go back and forth between nodes, I can only go in one direction. A good way to think about undirected graph is to think of as a highway between two cities where you can go back and forth. On the other hand, directed will be a one-way street where you can only go one way. Another way to think about it is Facebook. What kind of graph do you think Facebook has? Well, it has an undirected graph because when I'm connected to a friend, that friend is also connected to me. It's not one way. What about Twitter? Twitter is more directed because if I have my profile, people can follow me and I can follow people, but if somebody follows me, I don't automatically follow them. So Twitter is more directed. Another way to describe graphs is the idea of weighted graphs, unweighted and weighted graphs. And as you can see from the images, values can be applied to various aspects of a graph, not just the nodes. Remember, the nodes can carry any type of information, but with graphs, you can also have information in the edges, in the connections. Maybe you're going on a trip and trying to figure out the most efficient way to visit sites that interest you. Well, in that case, Google Maps would use a weighted graph to decide what is the shortest path for you to get there. And these sort of graphs are used a lot in calculating optimal paths. The fastest way to get to, let's say, 1 to 6. Lastly, another way to describe a graph is cyclic or acyclic. When you have vertices connected in a circular fashion, it's called a cycle, when you can go from one node to another, and then back to that original node. Versus acyclic, where you can't do that. And cyclic graphs are really common in especially weighted graphs, such as Google Maps, because most of the time there is a way to get back. So now that we understand a few ways to describe graphs, let me show you my favorite graph of all time. This is my favorite graph. It's by the Opti project, and it is a partial map of the internet. If you look here, you see that we have IP addresses connecting to IP addresses, and these are all nodes connected to create the internet. Pretty spectacular, right? That is the best example of a graph. So now that we understand, or at least have a basic understanding of graphs, let's do a nice fun exercise. Welcome back. We have our best friend, Visual Go. And once again, they have a great diagram for us to play with. Now, I'm going to give you 4 different graphs, and you're going to have to tell me what type of graph it is based on what we've learned so far. Whether it's weighted, cyclic, undirected, directed. So let's start off with this one. What do you think this one is before I show you the answer? Ready? All right. Well, this is an undirected, there's no arrows, unweighted graph. And you can see that it's also cyclic because you can go 0, 1, 2, and back to 0. What about the next one? What type of graph is this? Well, this is an undirected, weighted graph. That's also cyclic. So you can see that we have weights on the edges here. There's no arrows. We can go anywhere we want, back and forth. And we can also make cycles. What about this one? This is a directed graph, but unweighted. And yes, even 6 and 7 are a graph. But we see here that it's not cyclic, it's acyclic because there's no way for me to go back. Let's say 0 to 1, I can't go back to 0. All right, last one. What about this one? This is a directed, weighted graph. We have the weights, it has direction, and when it comes to cyclic, nope, there are no cycles, so it's acyclic. All right, the final challenge. What type of graph is this? Ready for the answer? This is a directed acyclic graph. There's no cycles, it's directed, and it's a graph. And this directed acyclic graph is quite common and called DAG. And actually, a project like IOTA, which is a pretty popular blockchain project, uses this and uses fancy words like directed acyclic graph. But at the end of the day, that's not that impressive anymore, right? We know what that is. Just simply a graph that goes in one direction. I think it's time for us to learn how to build our own graph. I'll see you in the next one. Bye-bye. Welcome back. Let's learn how to build our own graph. Graphs, when you look at them, look very intimidating. But here's the thing. We've actually learned the tools necessary to build graphs, because graphs are built on top of other data structures. Remember this diagram of the directed acyclic graph? Well, many of the data structures that we've been playing with up until now can create something like this, using trees and linked lists. I mean, it looks pretty similar, right? You have a node with children and different pointers. Using that knowledge, let's talk about how to start thinking about graphs, or at least how to think about building them. There's 3 ways that you can think about it. The first is called an edge list. And I have an example for you that we can use to build something like this. Let's say we want to build this graph. How would we go about doing this? With an edge list, we can say const graph equals to something like this. Now let's see what I did here. I have an array, and within this array I have 1, 2, 3, 4 items that itself they are arrays. But if we look at the graph, the array simply states the connections. That is, we have 0 and 2 as the first item in the array. We have 2 and 3 as the second array inside of the array. And then 2 and 1 and 1 and 3. An edge list simply shows the connection, that 0 is connected to 2 and 2 is connected to 0. 2 is connected to 3, 3 is connected to 2, 2 to 1, 1 to 3, so on and so forth. Quite simple. There's another way called adjacency or adjacent list. And in this case, we can create a graph where the index is the node and the value is the node's neighbors. What do I mean by that? Well, in here, we can use arrays, we can use objects, we can use linked lists. But let's say that in the index of 0, the first item, 0 is connected to 2. The index of 1, that is node 1, is connected to 2 and 3. Index of 2 is connected to 0, 1, and 3. And then finally, index of 3, or node 3, is connected to 1 and 2. And you can also do the above with an object, where it might even be clearer. And if a node value is something other than a number, you can actually give it a value, so a key and a value. And this is extremely useful with object if you have, like I said, not a sequential number as we do in this example. And when we implement our own graph, we're going to use an adjacent list using an object, and you'll see what I mean. Finally, I want to show you the last method to represent graphs. It's called adjacent matrix. And an adjacent matrix is going to look something like this. This matrix is simply going to have zeros and ones indicating whether the node X has a connection to node Y. 0 means no, 1 means yes. And if you have a weighted graph, you can actually add weights here instead of 1 and 0, so they can actually be numbers. I'm not going to type this out because I'm going to bore you to death, but here is the same representation that we've done with edge list and adjacent list, this time with adjacent matrix. What does it mean? Well, index of 0 has connection with 0, 1, 2. So 0 is connected to 2. Then node 1 is connected to 2 and 3. Node 2 is connected to 0, 1, and 3. And you can see how it's very similar to here. And node 4 is connected to 1 and 2, just like over here. And once again, instead of arrays, you can use objects here and actually give it a key and a value. So that this, if it was an object, would be 0, 1, 2, and 3. And if we go to Visual Go, you'll actually see that they have these 3 ways to describe graphs. The adjacency matrix, and because it's weighted, you see that there's numbers here instead of 0 and 1. We have the adjacency list, where it looks like here they have a hash table with the values, and also an edge list with an extra property of the weights because this is a weighted graph. And you can see the weights as well in the adjacency list. But we've just taken a look at a lot of numbers. I think it's time for us to build our own graph to finalize our understanding. I'll see you in the next one. Bye-bye. Welcome back. It's time to create our own graph. And I've created the template here for you. You can also create your own if you want, but I've only included things that let you focus on the critical part. We have a graph class and a few methods that we're going to have to add. Now, we're going to recreate a graph right here. A undirected, unweighted graph like this using adjacency list. And for the adjacency list, we're going to use a hash table. So how are we going to go about doing this? Well, I have a few things that I've set up for you. One is that in the constructor, we have simply number of nodes that we'll have to increment just to keep track of how many nodes or vertices we have in our graph. And also, I've created the adjacent list for you, which is an object. And as you do this exercise, you're going to realize why we want to use, let's say, an object versus an array. Because if we start removing things from the graph or placing things in the graph that's out of order, it's going to cost us a lot. Remember, arrays on shifting and shifting is expensive. With objects, we can quickly find items and see their connections. So that ideally, in this case where we have 3, or let's look at 0, in this case we'll have 0 is going to be connected to an array of its connections, which will be 1 and 2. So it'll have something like this. Your task is to add a new method called addVertex that adds a new node or a vertex. The naming here kind of goes back and forth. And then also addEdge. That is to add a connection between node 1 and node 2. And keeping in mind that this is undirected, if I could spell, it's an undirected graph. So both node 1 and node 2 point to each other. And if you scroll down here, I've actually created the calls, the function calls that we're going to do. We've created the graph, and then I'm creating 0 all the way through 6, just like we have on the graph here. And then we're going to add the edges, that is the connection between everything. 1 is connected to 0, 0 is connected to 2, 6 is connected to 5. Simply just saying this. I'm never repeating myself. That means I'm never saying add 3 and 1 and then saying add edge 1 and 3. I only say this once, and that's the key. And also the order doesn't matter. If I switch the order of these calls around, it should still give me this graph. All right, I know you're excited to get coding, but the final thing, and this is only optional, if you want to do this yourself, you can also code it yourself, but it's not really that important for this video. I've created a small helper function called showConnections. And you can look through this function if you want. It's not really important to the core of the course, but I've made this so you can check your work. Because if I run this using, at the end, my graph, showConnections, it's going to print out the answer like this. And it's going to show all the connections of the graphs that you've created. And this way you can check that these connections, that is node 4 is connected to 3, 2, and 5. Node 4 is connected to 3, 2, and 5, just like we have here. All right, that's enough for me. Good luck on this exercise, and I'll see you in the solution video. Bye-bye. Welcome back. How did you do in this exercise? Were you successful? Were you not? Here's the thing. This is actually extremely simple, but it looks overly complex. And that's a general trend with graphs. They look really, really intimidating at first and really hard to really think about them in your mind. But once you put things down, understand things, maybe draw things out, they're actually quite simple. And they're very similar to what we've learned up until now. Everything we've learned about hash tables, arrays, trees, linked lists are all part of graphs. And graphs simply use those data structures. For those of you that weren't able to solve this problem, it might be because you were a little bit intimidated as to the task at hand. But let me show you how simple this can be. In order to add a vertex to our adjacency list, all we need to do is to simply say this.add, or this adjacency list is going to have node. So we're adding the key into this object of the node that we want to add, and that's going to equal an empty array. Because when we enter a new node, it's not going to have any connections initially. We want to add the edges afterwards. And then finally, we want to increase the number of nodes by 1. Now we have 1 more. That's it. We've just created our nodes. Look at that. We have 0 all the way through 6, and they are in our graph. Unfortunately, none of them connect to anything. We've just created the nodes, but none of the edges. So let's go ahead and do that. With the edges, because this is an undirected graph, what we'll have to do is say this dot adjacent list is going to say node 1, that is the first node that we're giving. And the node 1 is going to push. Remember, this is an object, so we're getting the key. So that is, let's say this is node 0. It's going to push to the array of connections that node 0 has and say that it's going to be connected to node 2. And because this is undirected, that means we have to do it the other way around as well. So we simply copy this. Let's make this a little bit bigger so you can see. And we simply reverse things. So node 2 is also connected to node 1. If I press run here, look at that. We have our graph. How simple was that? That wasn't bad, right? And I mean, we could create this in a linked list if we wanted to, but the concept is the same. If we look at 0, that is connected to 1 and 2, we can confirm that 0 is connected to 1 and 2. If we look at 1, 3, 2, 0, 1 is connected to 3, 2, 0. And let's check maybe 5, which is connected to 4, 6. 5 is connected to 4, 6. And there it is. We've just created our very first graph. When it comes to interviews, graphs aren't as big of a topic as the other data structures, mostly because they take a bit of time. And questions regarding graphs can be overly complex. That doesn't mean that you won't see them, but they are rare. However, by knowing the basic fundamentals, what types of graphs we have, and how you might create graphs, how you might want to hold data in graphs, such as adjacency matrix, adjacency list, and edge list, you already show that you have the ability to understand graphs, which is an advanced concept. Now, because graph questions aren't that big a part of interviews, we won't be spending any more coding time on it. But also keep in mind that we have a section coming up on algorithms where we're going to dive a little bit deeper into things such as breadth first search and depth first search, which can be applied both to graphs and trees. So if you feel like you can still learn a bit about graphs, don't worry, we're still getting there. But for now, congratulations on creating your first graph. I'll see you in the next video. Bye-bye.